So we're going to talk about serverless in production, and we have an interesting panel over here with a diverse set of use cases. And basically, the idea is to hear from you guys your experience around implementing business use cases using serverless. Let's talk about the challenges and the problem that you've seen along the way. Let's talk a little bit about the architecture, design concept, things along that line. And why did you choose serverless? Why is it a good fit for those specific business use cases? So I suggest we'll start with a quick round of introduction and then kind of circle back to start the use cases discussion. So, or maybe we'll start with you.
So my name is Or. I'm the co-founder and CTO of Skyline AI. Skyline AI is an AI asset manager for commercial real estate. We basically partner with top real estate players in the US to establish investment vehicles augmented by AI. The place where this meets serverless is basically our entire infrastructure, everything from the APIs that serve the platform to the ETLs that load the data to the actual data warehouse, and the platform which we are using to train the AI models is serverless. Basically quite varied, so backend and frontend, several cloud providers, and so forth.
Hi, Linda Nichols, Head of Application Modernization at Cloudreach. We're a global consulting company focusing on cloud adoption and innovation.
So I'm Ben Kehoe. I work at iRobot. We make the Roomba, which you may be familiar with. And we're entirely serverless in production, so I'm able to tell you about that. And I wouldn't be able to tell you about what we do in production if it wasn't serverless.
Hi there, I'm David Roberts from Chain.io. We do supply chain integration, so most organizations' supply chain is extremely complex. There's a lot of different companies and software providers involved, from getting goods from ordering it to the manufacturer, getting it overseas, and to the destination warehouse. So we make it easy and quick to integrate all these different players in the supply chain together. And we are 95% serverless in production.
So let's start with you, and you can start talking about the use cases.
Cool. So we have to solve this problem of we have all these different clients who want to integrate all these different types of software together. And fortunately, everybody uses the same software and the same API, and except they don't. Most companies have multiple software packages they're using, and a lot of them don't even speak over API. There's a lot of legacy technology involved, a lot of faxes and even phone calls sometimes. So you have to get creative with the integration. So what we try to do is create very small reusable pieces to say hey, if we try not, we don't want to drop down to this, but if we need to send a fax to somebody, we'll write a service that sends a fax to somebody. So what our architecture looks like is we have this core, and we try to keep the core extremely simple and focused, not a lot of complexity. It has a write endpoint that you can send supply chain documents to, like a shipment. It has a query endpoint that you can get the status of it on, and it publishes events out. And that's all it does. Then around it, we develop all these little microservices that we like to call adapters. And these focus on very specific things. Maybe one knows how to pull a file off an FTP server. Another one knows how to take a shipment from that core API I told you about and change it into an XML format that one of our client software packages use. So we keep all of these very specialized to do a very small function that we know we can reuse multiple times for other clients' needs and other software packages. So by keeping it small and having all these microservices, we can do lots of customization for each client and each use case without ending up with this giant mess of if client A do this, if client B do this, right? if a client has something specific they need, that's a new microservice. So then what we do is organize all of these very simple little microservices together to do more complex transformations and solve more complex problems. So I mentioned that core sends out events. It publishes them over Kinesis. And then we have this thing we call the adapter router, which based on configuration we set via a UI. It can determine, oh, if I get a shipment for this client meeting this criteria, I need to fire off this adapter that sends that XML to that software system. And everything's kind of, it's not completely decoupled, but like, it doesn't necessarily know how to create that XML or what's involved. All it knows is when this event happens, this is the adapter that knows how to handle the next step. So that's the basics of our architecture. And the reason we can move really fast from this is anytime a client has a new request, we need a new feature, we're talking, hours, day to stand up completely new microservice that handles a completely new problem to solve whatever feature they needed.
Okay, thanks. Let's move on to.
So yeah, so the Roomba, right? So we make a lot of them. And in 2015, we launched our first connected Roomba. So we've been making Roomba since 2002. And when we launched that robot, we launched with a full solution IoT cloud provider. And so this was, sort of soup to nuts, did all the things we needed for the connected robot, and had a little bit of scripting on it to do sort of extensibility things. Even before launch, we knew that they weren't going to scale to the volumes that we needed them to scale to, and they weren't going to be extensible in the way that we needed. So it would have been really hard to do an Alexa integration. So we had decided even before we launched that we wanted to move off that and onto something else. So we looked for both a new IoT connectivity provider, and then we knew that we wanted to build our back end for it. We wanted to take that in-house because we were interested in owning the ability to do whatever we wanted in the back end, and we wanted to do that on AWS. It turned out that a connectivity layer, the best choice for us was AWS IoT, which was convenient because it's also on AWS, but really had some features around our logistical chains, in particular for certificates between our factories, our contract manufacturers in China and AWS, things like that helped. AWS IoT is itself serverless. There's no knobs to turn for anything for scaling on it. And this was 2015. Lambda was very new. The serverless framework was still called JAWS at that point. And we looked at the state of services that were available on AWS and said, we think we can actually build everything we need to build with just managed services. And this was great because we don't have a background in scalable, elastic cloud applications. That's just not in our history. We're a device manufacturer. And so we were able to skip that by going to Lambda and have that in production and have that work just fine for us on things like Christmas morning, where all the robots that have been sold between like Black Friday and Christmas get opened all in the space of like 3 hours. And it goes super smoothly. And we run it with, single-digit FTE. It runs itself. We've learned that, we thought we were going to have to build circuit breaking logic into our code, but it turns out that circuit breaking in microservices is really about being a good neighbor, where you recognize that something downstream is down, and it will help it come up faster if you don't call it. Well, it turns out that like AWS is better than that. Like they don't count on their customers not calling their APIs when their APIs are down. And so you can, so we just let our Lambda functions call the services while they're down, and they'll get stood back up eventually, and then everything will work out fine. Our Kinesis queues back up during those periods, and then once everything's back up and working, it kind of flows back out. So there's been very little that we've needed to do to handle those kind of errors. At the same time, there's very little that we can do to remediate any sort of platform incident. Now, of course, it's absolutely critical that you own that outage to your customers, right? To your customers, you are down. And it's important for you not to say, well, it's not our fault, there's nothing we can do about it. You also need to make sure that your application is responding in the best possible way to an incident, right? You need to make sure that there isn't something weird happening because some part of the platform is not working the way it should. So there's still work to do when an incident happens. We're still completely serverless. There's going to be some day when we need a container to do something that we just can't get Lambda or any other managed service to do. And that will entail a significant increase in the number of operations we have to apply, even just for one of those. So we're not looking forward to it, but it will happen. It's still, we still approach it with the mindset of figuring out how to use a managed service if we possibly can. We like AWS Glue. That's another computation platform that we like that's all completely managed. AWS Batch is sort of an in-between place where you bring a container, but it's meant for something that has a finite period for running, so it can still be pretty managed. Yeah, I think that's a lot of the lessons we've learned.
Okay, so I don't know if you've noticed, but we've been growing. We have another member. So you want to quickly introduce yourself?
Nice to meet you, everyone. So I work at phone.com currently, and also I worked at ShopKeep before. In the last 3 years, I've almost exclusively used AWS Lambda and serverless technologies. It's been a game changer and paradigm shifting for me. I'd like to mention I saw a couple people here at Credit Suisse and other big banks that before that I worked 10 years at Deutsche Bank. So I get the big banks world, prime brokerage, services, hedge funds, large systems. So if anybody wants to talk about that and how it translates into serverless, I'd be happy to discuss that afterwards. Some of the use cases that I've had to deal with in production in the last 2 years, one here at phone.com is basically a migration of a very large monolith Perl application from on-prem to the cloud as a service, microservices approach in terms of how we design the software, as well as using serverless almost exclusively. And a little bit like Bustle Group did as well, we're also using API Gateway a bit as a web server as well. So we have also page generation being done from that perspective. And at ShopKeep, we did the backend for a point-of-sale system. So you can think about thousands and thousands of iPads out in the wild, sending out events about orders happening, people closing and starting shifts, being consumed and ingested by a single Lambda function that I no longer had to worry about scaling. Prior to that, it was a Ruby on Rails application. You could have, you need to have one instance per, multiple instances to deal with the load when it was very punctual. You can think about restaurants in the evening, Fridays, etc., doing a lot more load than during the day. So being able to feed and forget was a really a great use case there. Things to keep in mind is that most of the serverless technologies, it's about adopting HTTP and APIs and networks to be able to intercommunicate. So for example, for point-of-sale systems, sending in an order, if you need to absolutely keep it, which is required, you got to think about things like ACK and retry patterns or queues and DLQ as well to manage that server side. The other thing that I built in using serverless is a reporting backend. And one of the use cases, clients coming in and wanting to know about all of their data, but based on certain filter, dimensions, summaries, and enriched with certain information. It used to take, like, let's say 15 minutes if you want to take a look at all your data for the last 5 years, because it was kind of processed per instance and linearly. And then one of the patterns you can use with Lambda, which I found useful, but sometimes also of interest, is you can break down and partition a request for reports, let's say calculate one per day. And therefore, I added recursively called a set of Lambda functions that for a few seconds executed and calculated one day's report, and then simply recombining them into the final report the user was asking. So you can kind of borrow, let's say, up to like 5,000 computers to run for a few seconds almost instantly, which is not something you could conceive before, say, at Deutsche Bank, when I asked for one more server and I had to ask 6 months in advance in order to get it with all the prep steps that was required for that. So it's really game-changing technologies. Really happy that this happened. I strongly suggest people to look into microservices design pattern, domain-driven in that space, decomposition by subdomains. So you take a look at a subpart of your applications when you start to migrate to serverless, the cloud microservices, and you attack that layer independently from the rest of your domain. And also the things I found very useful is to constantly show the value that it creates to management and also other existing employees. As you work out, you have to remember it's a mind shift change, it's a paradigm change, so you're gonna have a little bit of internal resistance with the incumbent engineering group. So it's very important to show them the value and retrain them a little bit and keep on the messaging that it is a great technology.
Okay, thanks. Back to you, Linda.
So I have a little bit of a different story here since I'm in professional services and not any particular product. And also, kind of as head of AppMod, I'm a little bit higher on like the strategy and team leadership side. So if I got down in the weeds of how we do individual debugging, I would just be taking credit for all the work my employees are doing that is awesome. When really it's more like I say, you should use serverless framework, and then they use it, and when they run into problems, then I say, good job figuring that out. But really ideal, I have lots of clients that have lots of different problems and use cases. But I think it's really important to acknowledge, which I think this gets lost at conferences like this, where we're like, serverless is great, everything's serverless. In the real world, in the larger world, most people don't know what serverless is, don't know where to begin, think they should use it, don't know why. And so that's kind of how we help on the thought leadership side, is we kind of go in and you know, we're really more agnostic about the approach we take, because I don't have any personal gain if you use AWS or Azure. I'm going to recommend like what's best for your business. And so we're building serverless solutions on multiple platforms. And because of that, we have to know a little bit about each cloud platform and like what's good and what's bad. And I'm not really scared to say, you know, even with AWS in the room, hey, I think this is a limitation here. This is why this isn't good for you. This is why this would be better. You know, or, you know, we really just like kind of dig deep into the problems. But, you know, customer satisfaction and customer care is obviously something I care about. Cloudreach would definitely want me to say that. But I focus a lot on my team, and I'm a developer at heart, and I did architecture for many years before, you know, I was doing team leadership. And one of the things I really love about serverless architecture is that it focuses on the developer, because developers are lazy and developers do not care about infrastructure. And so when you tell a developer, hey, I really want you to focus on the code quality, I want you to build a solution, like, hey, you don't actually have to write the code for all the services you need. We're just gonna give you this toolbox of services in this thing called a cloud platform. You don't even have to use a specific cloud platform. And we want you to take all these Lego blocks, and we want you to do true engineering. Because now it's about software engineering, and it's not about just coding. And I'm just writing tons and tons of code for everything. And so I think this makes for happy teams. So yeah, we're building, you know, these systems that are performant and they're decoupled, but like I want to focus on the people, because when your developers are working on serverless platforms, they're really happy. They're doing like cutting edge stuff. It's innovative, but it just kind of like makes sense. Like, oh, I'm a developer, I'm an engineer, I'm now engineering things, I'm now writing code. But I think some of the things that, when we advise to companies about serverless, like we want to walk in and say, okay, you should use Azure Functions because of these reasons. But a lot of times we have to step back to the very beginning and say, okay, this is what your development environment should look like. And don't lose focus of the fact that you're an engineer and you care about code quality and unit testing and a CI/CD pipeline. All these basic engineering principles, sometimes they get lost when you're saying, hey, we're building a serverless platform. And so we help, when we're helping our customers maybe build whatever it is they want to build or modernize whatever they want to modernize, but we're also helping these development teams say, okay, everything that you know and everything you've been doing still applies. We're just changing the environment that it's in. And so, we help them get started, and then either we help them build the platforms or we build them ourselves. But I think, and this comes kind of back to the strategy side of things. I think that like ultimately, every functions as a service tool is similar, and every cloud platform has similar services. But you have to think about, not so much like, well, I don't want to get, sucked into this platform and then I can never move to something else. I just think that this idea of, like, I don't want to get tied into something only to have to move to something later is a real problem, even though every client we talk to says that it is. I don't want to do serverless. I don't want to do cloud native. I'm going to get really, like, sucked into this company. But, like, if you get married to Microsoft, like, is that such a bad life for you? Like, you were once, like, tied to this server that was, like, under someone's desk or in a back room or something. So,
you know what they say about Microsoft? That you can count on them to do the right thing after they tried everything else. So,
I don't ever say that.
just kidding. Love Microsoft.
But I think, I think each cloud platform, though, has their own advantages, but they all have, like, a pretty clear focus, too, I think, if you kind of look under the hype of serverless or cloud native. And I think that, I really care about developer tools, and that's kind of, we like serverless framework. We like this idea of developers being able to develop in a similar way across platform. But I feel like maybe Microsoft has a better hold on, or maybe they care more about developer tools. That's like, I think AWS is, of course, still the most mature. It's still your tried and true. Everything is just, like, figured out from start to finish, kind of. If I go to if I'm developing in AWS and I move to GCP, I have different options on GCP, but I'm always like, wait, where's this service or where's this other service? Because I just don't feel like there's as many options. But GCP, like, one of my developers said GCP is for dreamers. And, like, I think that's kind of a neat idea because GCP is amazing for data and it's amazing for AI. And maybe if your serverless architecture doesn't have to be as intricate, then maybe that's a good choice for you. And these are, like, and I'm talking about lots of different technologies, but it's a huge world out there, and sometimes it's really overwhelming to your average company. And and after you've been in this ecosystem a long time, it just becomes kind of easy, and just everything is serverless, and, like, writing applications the old way just seems so antiquated. But I would say, just step back a little bit and look at the world as a whole, and trust me, like, most of the clients I talk to just have no idea where they're even going to begin. But I think as far as use cases, though, we've seen everything. We've had people, really want us to build some sort of serverless facade on top of something extremely old, like super, like, banking industry, like COBOL old. Like, we've wanted, people wanted greenfield development, just apps. I want an API. I want a front end, on top of that API. And I think, in almost every single case, we've been able to recommend a serverless architecture that works for them. Different technologies, different platforms, but there hasn't been a case where we've said, no, I don't see where Lambda works here.
Linda, do you see different criteria when it comes to greenfield and legacy application? I mean, it doesn't make sense, I guess, to take any legacy application and to make it serverless. So what's the criteria?
Yeah, I mean, you can't just, take your mainframe and throw it out the window and replace it with serverless. But I mean, sometimes it's a matter of we just chip off a few pieces and those become, serverless services or something. Or maybe, like I said, a facade or a wrapper or an API layer that's completely built in serverless, but maybe that, old stuff is still behind the scenes because, like, it works great. And maybe we're just kind of chipping at this monolith for a long time, or, we just start from scratch, really. So, it's a different approach, but, like, I would argue it's just software engineering. Like, if serverless didn't exist and we were trying to, like, solve a problem, it'd be the same thing. We'd bring an architect in and they'd figure out how we want to tackle it.
All right.
Cool. Yeah, so At Skyline, we are, because we are a relatively young company, we have been fortunate enough to be able to design everything serverlessly from scratch. It all begins with an army of ETLs, so applications that extract, transform, and load data. Like a simple ETL would be an application that extracts data from, say, the US Census, and then it transforms it into, say, a CSV, and then it loads it to our data warehouse. And we have a bunch of these, and each and every one is encapsulated. It's like a standalone application, which is Dockerized, so it runs inside a Docker container. And we have dependencies between these applications. So for example, we might have an ETL that goes out and fetches the weather data, and then another one that gets the crime data. And these would be independent, so you could run them in parallel. But then you would have an ETL that generates predictions about asset values, and obviously you would only want to call that after the previous two have finished. So you have kind of like this dependency graph between those ETLs, and we were looking for a way to run them serverlessly. So each and every one could be stateless insofar as it satisfies the dependency requirements. So what we did is we built basically a platform that orchestrates the execution of those ETLs over a serverless container platform called Hypershell. It's kind of similar to AWS Fargate, which is rather new. And the gist of these type of platforms is that they provide you with a Docker-style API to run containers completely serverlessly. So where previously we would do something like Docker run, my ETL, now you would go Hyper run my ETL, and then you don't have to care about anything. They would basically take care of executing the container, running it. You don't have any idea about the infrastructure or anything like that. Really, really helpful. And then once all of the ETLs are running, they basically load data onto Google BigQuery, which is kind of like a serverless data warehouse. So you don't have to worry about indexing it or making the some parts of the data warm or anything like that. And then once the data ends up there, we have a team of data scientists who sources the data. They basically build models locally using Jupyter Notebook. But everything that goes after that, so the training and serving predictions live in production, is done with Google Cloud ML. So it's a serverless platform to train the models and then serve the predictions later on. On top of that, we basically have Lambda functions in AWS, which basically are the APIs for the front-end web application. And they speak with a managed Redis cluster that basically caches the predictions from the entire previous data pipeline. So yeah, we have been lucky in that we could actually pick and choose, the most appropriate solution from each different cloud provider. And we also had the luxury of building this way from scratch. We didn't have to migrate anything.
Okay, so let's talk about logging, monitoring, and troubleshooting. It sounds like your environment is pretty complicated. There's lots of functions, lots of different services. How do you troubleshoot? Do you use CloudWatch, CloudTrail, or did you have to develop your own stuff?
Yeah, well, indeed. I think one of the biggest challenges is that once you have an application running on something like Fargate or Lambda, then everything that's inside, it's kind of like a black box. For example, you cannot write logs locally because, what is a file system in a serverless world? And then in order to have the observability and the ability, for example, to debug remotely, you'd have to use all sorts of tools. So to do remote debugging, we're using a product called Rookout, which basically allows you to basically put breakpoints in something like a remote debugger and basically debug in production your Lambda functions. For better observability, to basically get a complete picture of what if you have a function, if you have an array of Lambda functions in a fan-in or fan-out pattern, where one function is calling other functions to do other stuff, and you want to debug this pipeline, then that could be pretty hard, or actually extremely hard, using just CloudWatch. So we're using a platform called Epsagon for that. It basically helps us to visualize the structure and analyze the logs. But I think the most important thing is the mentality shift. You have to change your mentality into such that, okay, I'm kind of like, I'm shipping this rover to Mars. I have to have, any kind of monitoring ability that I can put in there, I will.
All right. Ben, how about your environment? I mean, what do you use for troubleshooting?
Yeah, so we use a combination. We do extensive testing, and so we do local unit testing that's very extensive. And for that we're a Python shop, and we use a library called Placebo. And what Placebo does is it allows you to instrument the AWS Python SDK and put it in record mode so that when you make SDK calls, it records the result and puts it in a file. And you can put it in playback. And in playback, whenever an SDK call is made that matches the ones that you made, it will intercept those, not make the SDK calls, and just return the results in that file. And so we use that for unit testing so that our unit tests don't actually have to touch AWS. They're all local. For integration testing, we only do that while deployed because we use, depending on how you count, 30 different AWS services in production. And so it's far more than you would want to mock out locally and far more than you can mock out locally, which I think Chase was mentioning earlier. And so then the integration testing is run deployed. And different developers like a different mix. Some of them like to do unit tests really, really extensively, and then just do a few integration tests towards the end. Other developers like to do integration tests sort of from the beginning and iterate there. Things like Cloud9 have helped a lot for that, to make it easier to edit the code while it's deployed. For beyond that, once it's deployed and in production, we ingest all of our CloudWatch and CloudTrail to Sumo logic and use that for debugging production when those needs arise. So that allows you to sort of query over all of your data in arbitrary ways, which is really helpful. And that allows for a lot of metrics and alarms that would be harder to build in CloudWatch. And so we've found that pretty useful.
Okay. So another topic, we've been talking with lots of customers at Iguazio around serverless, and I think the common denominator is everybody are talking about the fact that using serverless can really reduce the time to market, can really help customers or the developer to focus on the business logic and so on and so forth. But what about pricing? I mean, you always start with a very small cost, but at the end of the day, once you scale, then the pricing is coming to the table, and it's a completely different picture. So I wonder what's your thoughts around that. Maybe start with Martin.
Sure. I've seen enormous savings in that space, especially the last 3 years. A lot of the applications I had were fluctuating throughout the day, right? So like VoIP calls at phone.com, it comes in the day, and then in the evening, there's not much going on because we're on the US market primarily. So what you have in Lambda is you pay per use, right? So we used to have about 35 servers running a certain logic to decide what to do with calls, etc. And being able to look at that from a Lambda perspective, we're at a total bill of about $200 per month, including API gateway to do that logic there. It's extremely little just for that segment of the total AWS bill. Versus what it would take to manage 35 servers, a disk having an issue, dealing with the replacement of the disk. You've got to take the total cost of ownership into perspective as well. It's very, very, very key. And part of that solution there is sort of like there's less DevOps involvement, and it's more like engineering, empowering your engineers to be sort of like product owners and breaking down smart applications so that they can support that as well. So you end up having less team responsible for managing your servers and more just for Lambda. So I've seen huge cost reductions, which you can funnel into hiring more resources. So you accelerate more development. And you can also, the nice thing with cost there is that you start to have the ability to do more full stack. It gets so easy to be able to develop a new function that does something, let's say, that an iPad might need to interact with, that I had like iOS developers developing a point-of-sale system, being able to create some of the functions, also in Python, to do the data that they needed, right? So you need less back-end, front-end, and ops teams integration, which allows you to minimize your costs in that perspective as well. So very important to take that into consideration. So that's confirmed from my perspective, like huge cost savings, which the business was very happy about.
Okay. David, you want to touch that as well?
Sure. Yeah, to be honest, I don't actually know if Lambda saves us money or not. I assume it saves us lots of money, but I haven't bothered to take the time to look because I kind of subscribe to what you said. Like I'm looking at the total cost of the developers and my cloud bill is extremely tiny compared to that. So I keep an eye on it, but I don't care too much about it. The things I need to optimize for are the developer time and what they can work on. And also for us, a big part of our business model is adding new integrations very quick. So, you know, even if there was some optimization there where somehow using something else was lower cost, by using Lambda, I can get the new features out and new microservices deployed very fast.
Yeah, that's to take the cost in terms of bottom line as well. Like another use case I just remember, one of our clients at one of those enterprises was top 10 clients in terms of revenue. And there was an issue in terms of like speed of delivery of certain features, and I just came in at that point, and there was kind of a client walkaway situation where they could have potentially left and lose that revenue. I ended up using Lambda Serverless to develop a couple of semi-custom solutions for them that would have been impossible to do in trying to modify the monolithic Perl application distributed in 35 physical server on-prem. And as a result of that, within a week, using a fairly junior developer, so not too much like an expert, I was able to make them very happy. They sent us twice edible arrangements, pots to the entire dev team to say, "Oh, thank you, that was incredible." And the accounts since then, in the last 6 months, tripled, and are now our biggest revenue customer, and now an advocate of us. And the reason was this, like, oh, you want something, at the end of the week, they add it. And the reason I was able to do that is because the way that it was constructed, it's you can't break the monolithic application. Everything is like monolithically deployed together. And I try to avoid services calling other services, which creates system dependencies, right? So you can iterate very, very quickly. You create a safe environment for developers to iterate when they can only blast very little. So the revenue gains from that, from making, I have so many clients that are like, oh my God, you turned that around like sometimes in 5 minutes. If I guess to me, like I can turn something very quickly. It needs to be taken into consideration when looking at the cost of saying, well, we might have that in 6 months because we have a 6 months release cycle. I'm exaggerating a little bit, but you get the idea. So cost is very, very relative in that space, given the iteration speed that serverless can bring when you make it very modular and monolithically deployed. Like remember that a Lambda, in the end, is a zip file. So it contains all of its dependencies with itself. So if you try to avoid to call other systems, you can update it very easily without risking the entire system.
So Linda, you're seeing lots of customers. What's your perspective on that? So how customers view those issues?
Yeah, I mean, well, and I've been in the industry long enough, I can kind of like harken back to the days of old, like 5 years ago, where I remember we architected a huge system, and at the time it was cutting edge. We had hundreds of APIs, but really maybe only 10 of those APIs were really hit with any frequency, from the front-end web application. But we had to pay to store them all. And now in a serverless architecture, we're only paying for those 10 and that are getting hit. So I see huge cost savings there. Also, I mean, thinking back to that application, we had to have an entire infrastructure team just to worry about, when things were running in a VM, and then when we moved to containers, they had to sort of build what our container fabric looks like. Then the developers had to learn Docker because their development environment needed to mirror the, environment production, so there's some developer time. So yeah, a lot of that overhead gets cut out. I mean, even as simple as if you're looking at a Node.js app, and you rebuild it on AWS, you don't even have to make an Express app. You just use API gateway. I mean, there's just lots of little, I remember spending hours building services that are now cloud services. So developer time, fired the infrastructure team, and then yeah, just your monthly bill. Yeah. But yeah, our clients are seeing. I mean, if you do a traditional data center migration, a lift and shift, then there's not going to be that much cost difference from one to the other, or it may even increase. But once we start moving, modernizing the applications or building new serverless applications, yeah, that monthly bill just, it goes down really dramatically.
So along those lines, I mean, when it comes to picking your cloud, how much customers are paying attention to being cloud agnostic? I mean, let's say that you start with Amazon, but after a while you want to move to another cloud. I mean, what's the customers? What's your perspective around that?
Cloud agnostic, I'm kind of married with AWS at this point. I'm hoping that IBM picks up, Oracle picks up, and it creates a good hyper-competitive environment, and it's more like price downs than trying to lock us up. I've done some level of normalization. When my calls comes in, that's an important pattern. It really calls a wrapper Python file that then calls the function, and it normalizes a few things. I was initially going for protection against multi-cloud, but since then, because it's not just Lambda. You're going to turn around and use S3. You're going to turn around and use SQS. You're going to turn around and use any of the other services, right? So to really, you're choosing a family, and that becomes your network. You're battling versus other companies. So to me, I'm not worrying about it. I hear that a lot. Yes, and people are like, oh, we're going to lock into a cloud. But I remember having to deal for 6 months to renew a Sybase license at Deutsche Bank, and that was much more difficult to deal with than, let's flip to something else.
And I think a lot of people are, coming from traditional enterprise service agreements, right? Where, there was no public pricing, or the public pricing was ridiculous and nobody paid it. And now we're in a place where the, tier 1 public cloud providers all have very publicly listed price information that's all very reasonable. And so, the worst case, you're not getting squeezed for, an extension of the contract like you could be in some of those traditional enterprise agreements.
Yeah. But on the other end, I'm hearing customers saying that you need a PhD to understand the Amazon's bill at the end of the month. I mean, it's kind of...
Well, it depends on how much you need to understand it, right? If it depends on the cost, right? And it's certainly, so for us, we're a device company, right? And so we build hardware. And so we're very used to understanding our costs very far in advance because things cost, you make agreements with suppliers and stuff for very, stuff. And for our, finance department, our first interactions with AWS where, they said, okay, well, how much is this going to cost us? And, we had worked with AWS to get a model and it was like, well, probably something like this. And that was a big mindset shift, right? Where pay-as-you-go is often for, sort of web companies, just naturally, oh yeah, that's exactly what I want. For a company that's used to hardware, it's a big shift. And then we're also a company that because we make money off hardware, we count pennies, right? And so, how much it costs us per robot is important to know and important to forecast because the robots live for a long time. And we don't charge for our cloud services today. And so forecasting that cost and understanding it and reducing it has been important. But at the same time, where we're at, we don't spend a ton of time optimizing our Lambdas because our Lambda costs are not outrageous. And so we're better off spending time creating new features for our customers to increase the value of the cloud connection that they have rather than, trying to squeeze every possible, 100 millisecond increment out of a Lambda that we can. So I think, certainly AWS billing can be a little inscrutable. Having many accounts helps, right? Where you start to split costs across accounts.
Maybe set a free tier to them.
It was sure. We have not been in the free tier for a very long time.
So every time iRobot's stuck in the table, it means that thousands of Lambda functions are hitting the...
By the way, I think when it comes to pricing, to me, the priciest thing that could happen is if I would have downtime, right? So, the fact that we have to manage less servers and the stack becomes a lot simpler, it means less mistakes, it means better uptime, and eventually, it's worth the cost, right? If I have to manage, if I manage to save 20% during the entire year, but then it means I have 1% more downtime, then I'd rather have 100% uptime and avoid that, pay more.
And it's really a paradigm shift. I still today, some people that are still managing the on-prem parts that we have for VoIP, they raise a change request, for example, to get approved. Oh, go change a disk, it's got bad sectors. And they think they're creating value. They're like, oh, I'm going to go at like 9 p.m. to go switch that thing and do that while you guys are like, it's the psychological part of it. It doesn't exist as a concept anymore. Like to me, like you forget that thing. What's the default port for SSH? I forgot. I think it's 22, right? So like it's just completely paradigm shifting. That's would be my main message. Is I understand where you were. I was there after Deutsche Bank. I did a startup and it was J2E across the board. I regret it very much so. But it took time, but I flipped around, and now I see, like, no, it's not about controlling a monthly cost. There's so much savings and so much agility and so much, you can get talent that is a little bit more junior, and so there's a cost savings there because a lot of concepts don't need to be in their stack and their resumes. It's just take it from a full picture and then talk to us. I am not sponsored by AWS or Serverless, etc. I've lived those things for real for the last 3 years, and there's huge cost gains across the board.
So speaking about paradigm shift, when it comes to security, I mean, especially enterprise organizations that are used to certain security policies, when they do start using serverless, what's the best practices around security?
I think, first of all, when it comes to serverless, we're mainly talking about application level security, right? Because most of the security that's beneath that level in the bottom layers is handled by the cloud provider. Having said that, if you come from enterprise organizations which are used to things like WAF, like web application firewalls, and things like that, there are a few solutions out there that offer kind of like an application level WAF. One such service that we're using is called PureSec, and which basically provides monitoring and rule-based traffic blocking, kind of like similar to what we are accustomed from the WAF world when using CDNs or lower level infrastructure. So security is easier, like many other things in serverless, because you only have to worry about the topmost layer. But there are still some challenges there that aren't yet addressed by the cloud providers natively.
I think so. There are a lot of these startups that are doing serverless security, and I think something that's lacking there that servers do have and containers do have as well is the ability to sort of insert below the level of the code that's being placed on it, right? That for PureSec or a number of the other security startups in that space, the ability to know that the PureSec agent, for example, is running inside that function is non-trivial, right? So how do you know, you can put that in there, and when it's running, it's going to do its job, but knowing that it's in there and functioning properly is not something that's easy for the security team to guarantee. And so providers, this is again something that, when you're serverless, you sort of need to wait till a provider, understands the use case and implements it. When Lambda has some sort of plugin architecture where a security team can say, here's this plugin from PureSec, I need you to run this underneath any code that a developer brings, then there's going to be a way that they can, have a policy that puts that in place for every Lambda that's out there, and they can know that it's doing its job. The other piece that we're also missing is that these code tools, which is the only place that we can bring security tools into our infrastructure, they understand what the code is doing, but they don't necessarily understand the rest of the infrastructure, where when you have a DynamoDB table with a DynamoDB stream that goes into Kinesis Firehose that goes into S3, there's no code touch points in there for us to bring a security library in. And so there are tools that look on top of that to your infrastructure graph at what your infrastructure is doing, but at the places where it touches your functions and disappears into your code, those tools often don't understand your code on the other side. So these sort of two pieces on both sides of the issue that are slowly starting to get brought together by some of these startups in the security space, but we're not quite there yet.
Also add the developers need to understand security a lot better. IAM, at least in AWS, is pretty complex, right? And it's something that before you had an ops person who would set up the security. Well, now if we use serverless framework and Terraform, for example, and developers are routinely editing those files and deploying new services, right? Because it's serverless, so it's very easy to just put up something new. So you have to teach every developer, like, putting S3 dots, S3 star is not acceptable, right? And that has to be part of the PR process. Like, hey, look at this YAML file. Is this an okay security practice? Make sure everything is locked down to the lowest level it can be. And that often takes a lot of experimentation and like kind of just deploying things and figuring out what the lowest has to be. Sometimes no matter how much you read the documentation, I have no idea what permissions are needed to invoke a Lambda in a certain way.
There are some tools that are out there that are purporting to help with that by generating your policies from the code that you're deploying. And that's super handy for exactly this reason, but it also carries the danger that, okay, well, if someone wants to put malicious code in there, you're going to generate the policy that allows the malicious code to do what it's trying to do. And that's not going to help you be secure, right?
I think net security is it's better and possibly a little worse. And the better is that effectively you don't have to deal with server physical security, someone breaking in. You have to remember 90% of hacks are internal employees doing that, so now no longer access to machine stuff, USB, take all the data drive out. Like I've heard crazy stories in my life, so real ones. And so that's all taken care of. There's a great slide out there that shows sort of like all the security aspect from like on-prem management, and then at the end you get Lambdas, like application layer 3 things, and that's it, right? That said, Lambda, and when you start using it, you start to see as everything is an event. You look at the business, oh, it's a phone call app, and a user requested a page. It's an event. Everything's an event. So it brings you to thinking in microservices, domain-driven design, breakdown by subdomain, bounded context, and certain services. And then what happens is you have clients, and those clients wants to do things as well, so you start exposing an external API. Where I'm going with this is that most likely your service facade you're going to build internally to serve your internal applications. Part of it, you want to expose it externally. And Lambda in itself sort of runs in the internet, right? You have an option to either run it outside of a VPC, a virtual, I don't get Ben, probably knows about that, or inside. At Shopkeep, I run it outside. It's nice, cold starts are easy, but when you run inside of a PC, there's a longer cold start aspect, and so this is a pretty conversation I won't bring right now. But where I'm going with this is that you're going to want to expose some stuff, and it's easy because it's already out there sitting practically on the internet, and users or clients are happy to use some of your services for their more advanced use cases. So what does that mean, right, into security perspective? You're going to have to start to support multiple security model. You might want to say, oh, this is like internal apps, allow them to do anything against my service layer. This is some clients, part of that is my client API, only if they have an OAuth token, XYZ, then let them in. Oh, that's my website, www.thephone.com, trying to do a sign up and asking for certain services, allow cores, allow this, and allow these services to be called. And this is my internal control panel, and give them a little bit more access. So what we end up doing is basically having one person who's responsible for the platform, kind of-ish, a little bit DevOps world, a little bit, which is basically the technology tooling that our then user developers are using, and his role is to own security in that space. And we have authentication logic that allows detailed, are you authenticated because you come from our internal control panel? Are you a cron or a scheduled Lambda function executing from Cloudreach triggers? Are you an external user requesting a page for our main open site? So you get a little bit more granularity in that space. It's feasible and doable. And you have options to either, let's say, use an API authorizer inside of API gateway, custom authorizer, or embed it inside of your wrapper around your function, which is nice as well because you still don't create a system dependency on the API authorizer and API gateway. So you could probably end up wanting to have a detailed access level and having to manage that, but it enables so many cool use cases that will create value for users that it's worth the investment, but you should look into it. And tooling is not that well advanced in that space. It's probably something you'll have to build a little bit internal to your security use cases. And of course, things like least privilege, looking up CVEs, known libraries that get hijacked. Some Python stuff got injected in PyPL recently, so you want to monitor that, external dependencies you're loading in, etc. And maybe have a connection manager running on top to be able to trap that, and have a security officer as well. Nothing really changes there. You've got to manage security.
Just a note on running your Lambda in VPCs. So a Lambda without VPC doesn't have an incoming attack surface, right? You can't open a connection into it, but it can open a connection to anywhere, and you can't see it. Now, at the same time, so if you put it in a VPC, cold start issues aside, AWS will eventually solve that. If it talks to AWS services that don't have VPC endpoints, then it has to be able to talk to the internet, and there's no segregated IP space between AWS services and AWS customers. So you basically can't tell, I'm going to talk to Cognito, and Cognito doesn't have a VPC endpoint. So I got to talk out to the AWS address block, but I can't distinguish between talking to that and talking to somebody who runs on AWS. The day that everything has a VPC endpoint, I can run all my Lambdas inside a sealed VPC that can never talk to the internet, and they'll just talk to AWS services, and that's the dream.
Yeah.
That would be great. We're a long ways from that.
Yes.
One note too, because you mentioned Cognito, it just made me think of it. I remember many, many times in the past writing auth from scratch, and badly, and full of bugs. And the fact,
Who else?
yeah, I'm sure like anyone who's been in software development. So the fact that we have Cognito is like there's a bunch of security right there that's built in.
Yeah.
Cognito, Auth0, there are a lot of these companies out there doing auth as a service, and you should not be writing your own auth.
Yeah, never again.
So sounds like we're touching a very sensitive point. So let's talk. Yeah, we've got 5 more minutes. Okay. So let's start to wrap it up. So 2 more things. One is I'm interested to get your perspective around performance. We talked about security. Have you bumped into performance limitations, something that you wanted to do, but you couldn't do it because of the limitation of the number of functions that you can run with Amazon or Azure?
So performance, right? That's one of the use cases I mentioned earlier. Again, everything is parameter shifting in this business. It's crazy, right? Like I mentioned earlier, having had to do a report for I'll tell you my sales by major category and pivoted on who sold it, right, for Shopkeep. Now you can actually split that up on 5,000 and the functions that I use for a second, right? Okay, maybe I'm running it in Python, so it's a little bit slower than Go on etc., right? And I've got network overhead to do with etc. But still, I get access to compute farm on demand that I'm paying maybe 20 cents for a given report that the user gets right away instead of getting in the middle. We will stage you a link once the report is ready, right? So that used to be the use case. So performance is not just the extent, it's the things you can do when you have access to a compute farm. That caveat, be careful with that use case.
You gotta allow me to do that.
Thanks. Fixes everything electronic, this guy. Do love my little Roomba, by the way. So take that into consideration. Remember that pattern is really, really powerful. You just kind of do a recursive call, but you distribute it. That said, on this one, going back to cost, make sure to set up billing alerts and that you get notified in some form on any kind of exceptions, including you've reached out the max concurrency level. Because when you do that, you can loop or have a bad recursive end case, and then your thing runs forever. I had a friend who actually, I told him that pattern, he tried to use it for one of his use cases, and he didn't close his recursive loop correctly, and having a really big bill at that point because of that, because some functions kept just running forever. So it's be careful there on that one. Otherwise, performance, you can get like pretty much like 3 gigs memory size, a pretty big CPU. I haven't had like major issues there, and we do like call management systems to get a feel a little bit real time. Yeah, I've been happy with the performance there.
A note about the Lambda memory size. The memory size on Lambda turns a knob for both memory, CPU, and network. Yeah. And so if you are CPU constrained, turning up that knob still helps you.
Yeah, that's the way it works is you get access to, say, per increment, you get 8% of a CPU. So if you keep on maintaining it, you'll get a bigger increment. And to note is that if you get a bigger instance, your cost per 100 milliseconds is going to be higher. But at the same time, you might finish quicker. Yeah. So you get kind of like nets off in the end. So I usually just use one of the bigger instances in my case.
Start big and turn down rather than starting small and turn up.
Yeah. That's a good advice there.
So I think the thing to keep in mind with serverless performance is you're talking about an individual request, not your overall process. So compared to like say a Ruby on Rails server that maybe had you were running with 8 gigs of RAM or something. I don't even remember what the T2, EC2 instances are anymore. But that's split between maybe 50 workers, where if you have a 256 megabyte Lambda, that's for a single request, and you can still have 1,000 of those at the same time. So I don't think performance for an individual Lambda or serverless function is really any issue. Where you do run into problems is that it's really just having smart architects or smart event-driven architecture. I'll give an example of a bad case that I did initially. Like I said, we have everything composed into very small lambdas. We have over 200 lambdas. So at one point, I got carried away with synchronously calling lambdas, and I kind of had this chain of a lambda, caught another lambda, and several of those were inside of VPC, which has bad cold starts. That's where you can really run into problems if you have, I think a VPC cold start might be like 10 seconds around that.
And you don't pay for idle with a Lambda, but you do pay for wait. If you have a Lambda calling a Lambda, while the second Lambda is running, the first Lambda you're still paying for.
Mm-hmm. So these were short-lived, so payment that the cost wasn't a huge issue, but it was definitely slowing things down, and it got to the point where something might have, it was almost like a 15, 20-second request. So, we just had to re-architect a bit to handle those things.
On that one right there, it's there's a lot of 50-50 things out there, right? They say single database or one database per microservice, etc. Another one is like nested calls or a good old style service-oriented architecture with end tier, lower level, middle range, middleware, and then high level business functions. In my 3 years, I've tried a little bit both. The one that I like the most is it kind of has an term called modular monolith. And if you Google that with Simon Brown, it's kind of a London-based software architect, you'll find a really good presentation. Also, Martin Viau has something on that as well. And it's basically about having if I say my service creates an account and I need to purchase a phone number and then make a payment, instead of calling all those services individually, and we are in a VPC for various reasons, including HIPAA, etc., and hitting those cold starts we mentioned, by importing those services underlying functions code monolithically, you deploy monolithically, then it contains as if you called the service, which itself still exists for other more direct purposes by, let's say, your admin or your client API. But internally to your service layer, right? You create like a service facade, and then you divide by subdomains, and then you say, these are the things that we should do as a business that does VoIP and that does an external API, etc. And those guys shouldn't call each other. You can have other external apps or internal apps call those guys, but if those guys start calling each other, it gets really complicated, and you can have issues such as cold start as well.
So we need to wrap up. So just last question, and we'll do it real quick. What are the missing features in serverless that you would like to see in the near future from the serverless vendors? Let's start with you.
I think so. One use case that we're currently are struggling with is interop with binary languages. So, for example, we would have an API that has to talk to a C application that does some heavy lifting for things like feature selection. And today, these are the kind of things that we're doing with Fargate or Hyper. These are the sort of things that we would like to see in Lambda as well. And also, I would say, one great thing about Lambda is it really pushes you to better design in the sense that you have to work really hard to make everything as stateless as possible, because you cannot share memory between functions, certainly not a lot of it, but sometimes that doesn't really work, right? So if you need to have an API that would indeed, have to read only from the RAM to be able to, reply in microseconds, then still you would not be, today you would not be able to use Lambda for that, right? You would have to use some kind of a caching mechanism like Redis. Yeah. So yeah, maybe, trying to, maybe if the cloud providers would allow a more generous memory limit, that would also help.
Yeah, so I can tell you that you can try Nucleo for that. So that's another alternative that pretty much solves the problem. So.
Yeah, I think, while I will say repeatedly that I never want to spin up my own container or create a container, I think being able to create your own runtime like OpenWhisk is something that's missing natively on all the platforms. I know Google has serverless containers in alpha, and I think that's going to be huge because I think people need to do that. Not me, but other people need to be able to create their own runtime when necessary.
I think the functionality for service mesh that comes from something like Istio and Envoy and Kubernetes is missing for serverless when you're talking about managed services across multiple accounts and managing the discovery and auth for those things.
Say a truly serverless relational database. There is serverless Aurora, but I wouldn't call it quite serverless.
It also needs an HTTP interface so that
Yes.
it works well with Lambda.
Yes.
I was going to say having all your dependencies also serverless, because in the last 2 years what you end up is like, hey, I can spell like crazy, but then your database, if you're using a centralized one, does not necessarily do it, and that becomes potentially a bottleneck. One of the things that he's mentioning is like Aurora serverless, kind of like adds CPU capacity or database engine capacity on demand, but it's just recently got GA, and it's something that hopefully they'll get right. Cold starts should be the done concept, doesn't exist anymore, we love, especially including inside of a VPC. Integration latency between API gateway and Lambda, more controls there as well. Sometimes also be careful, you might get a 504 gateway timeout from API gateway into Lambda because it goes over the network, it's not one system, right? And so you could have like a network bleep app and some monitor for the 504 there, so you can get a couple of bleeps in that space. And just, hopefully continued cost pressure by competition and lowering the cost in that space, and then a little bit better tooling as well. As with many people, and the guy from Basel, I built my own little tooling initially, and I'm just starting to look at the existing frameworks and see, okay, maybe it's mature enough to go there. That would be my ask.
All right, so now we really need to wrap up. So thank you very much. It was my pleasure. Thank you.